Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. This time we're answering a couple of questions related to our recent programme on gravitational waves. These are the ripples in space-time predicted by Albert Einstein, emanating from the interactions of massive bodies like black holes or neutron stars. Scientists have been able to detect gravitational waves from billions of light years away using laser interferometers here on Earth. As mentioned, our show on this topic sparked a lot of questions from our audience, and the first one we're going to tackle is this.
Hello, Naked Scientist. Paul here from Toronto. Related to your show on gravitational waves, how is the energy conserved so well that we can detect gravitational waves here on Earth from interactions of massive bodies on the other side of the universe? This when other things, for example like friction, convert movement energy into heat energy so quickly. Thank you.
Thanks, Paul. Brilliant question. Would the energy of gravitational waves start to diminish so that we could not detect them by the time they reached us? I put it to Ben Alanak, Professor of Theoretical Physics at the University of Cambridge.
The energy released by, for example, the collision of two black holes is absolutely enormous. For example, in the first measured gravitational wave, where two quite massive black holes coalesced into one, it's inferred from the data that about 3 times the mass of the sun was converted into energy and released into gravitational waves. So that's enormous. So that's why you can measure it with a very sensitive measuring device, even such a large distance away. That combined with the fact that the experiments are so sensitive and can measure change in distances of the space, or stretching of the space to 1 part in 10 to the 17.
So you're right, Paul. The energy of gravitational waves, like all forms of radiation, dissipates over large distances. We just need sensitive enough instruments. This was evident in the first detection of gravitational waves, where the merger of two black holes 1.4 billion light years away caused the LIGO laser to shift by a distance smaller than the width of a proton. Thanks for that. For our next question...
Hi, this is John Bondi from Vermont in the United States. My question is, do gravitational waves also experience a redshift just as light waves do? Can we measure the shift as we do with light with emission and absorption lines? Thank you.
Another lovely question from John. Redshift refers to the increase in wavelength of electromagnetic radiation, like light, travelling to Earth from the most distant objects in the universe as it expands. As you say, we can use spectral features, like absorption lines on a colour spectrum from red to blue, to measure how much the wavelength has changed. But does the same apply to gravitational waves? Back over to Ben Alanak for the answer.
Gravitational waves do experience redshift, just as electromagnetic radiation, such as light, does. You can't use emission or absorption lines, though. Electromagnetic radiation has that because it's produced in atoms, which, because of quantum mechanics, gives you discrete choices for the wavelengths depending on which atom it is and so on. But you don't have this in the gravitational setup. So what you do instead is you try and work out which galaxy the gravitational wave came from. And if you can find that, you can find out what the redshift of that galaxy is, and the redshift of the gravitational wave will be the same because of it'll be equivalent from the point of view of the expansion of the space-time.
So, John, the wavelength of gravitational waves increases as they travel across an expanding universe, just like light waves do. Unlike light, however, they don't have emission or absorption lines that we can use to measure the redshift directly. We may be able to infer it, though, by comparing it with electromagnetic signals from the same event. Thanks for those brilliant questions. If you'd like to keep the discussion going, why not join in on the thread on this topic over on nakedscientists.com/forum. Next time on Question of the Week, we're answering this one from Bhavesh, voiced up by a member of our team.
How do guided missiles reach their targets?
And we look forward to that one. If you have any questions of your own, why not send them in to chris@thenakedscientist.com, and you could feature in a future show. Until next time, from me, James Titko, thanks for listening, and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.